Okay, so what I've done now is I've just gone through and I filled in the rest of the aliens. I've got 5 aliens, 5 items, work out the master code and the pieces of paper also put in, and I've got the rooms. So as you can see, some rooms contain items, some room contains aliens, and a couple of rooms contain aliens and items. So room 11 is alien 2 and paper 1, and then obviously the last room, room 24, is the master computer. How the links thing work is links is a list itself, and we add to this list these links, so these link items. So this link item, room 1 and room 2, are linked with a west facing door. Room 2 and room 3 with a north facing door. What this actually means, if I just exit presentation mode and show you this, so room 1 and 2 is actually linked here with a west door. So those two are linked, and 2 and 3 are north. What the link class does, it's clever enough to know if room 1 and 2 are linked with a west door, it will automatically create the link from 2 to 1 with an east door, and the same with the north and the south. So you only have to put in one door and then it works out the rest for you. So if we go back here, so these links have all been created, so that should allow us now to use these to actually create the game. So first thing we need to do is set up the player, and the player will have a backpack. So let's stick in the backpack. So backpack equals, and that's also going to be a list item. So let's have that as an empty list item to start with. Then we're going to set up their health. So health is going to be equal to a random integer between 0 and 6, and then we're going to add 10 to that, and the same with the attack. So basically when you start the game, and then 0, 6, add 10, this will manually create your attack and your health. And then what we need to do is we need to set up the first room. So how this works, we're going to have this object called, well, this variable called current room, and that's going to be room 1. So current room. So the current room object we're going to change. So when you move from room 1 to room 2, current room is going to become room 2, and that's how we're going to be able to use our object orientated code. So let's first of all set up a variable called game over equals false, because we're going to need that for our loop, because the whole game loop is going to be a while loop. Let's upset this variable called clear equals, that's our escape character, that's basically new line, and if we do times 50, that will basically write 50 new lines. So that will allow us to keep the console clear. So let's do our loop. So while not, game over, and now we're into our game loop. So let's think about what we actually want to do. So the first thing we want to do is we want to print clear each time we go round, so we get a nice clear bit of line, and then I actually want to print out your current health and attack. So health, so let's get the health, so string, so we can actually print it out, concatenate it with the thing. So health and attack, and attack is going to be string attack. So that will display in each room the thing. So if we recall what we wanted to do, if you recall the flow chart, we want to display the room description. I want to check for alien and fight the alien, check for item, check for the master computer, and then finally get the input. So let's do get the input first. So get the input, we're going to have basically how this is going to work, we're going to get the input and we're going to do a loop until they move into a new room. So how we're going to do that is we're going to do this. We're going to say not valid equals true, and then while not valid, we're going to get the input. So the input is going to be saved to a variable called choice. So choice equals input, what do you want to do? And I'm going to stick a dot up on the end, so whatever the people type in, it will automatically be converted to uppercase. So this is where they can type in either N, S, W, E to move rooms, or they can also type in some keywords. So one of the keywords they could type in is backpack. So if choice equals backpack, that's going to display the backpack. So tab that in. Two equal signs for the equal operator. So for the backpack, to show the contents of the backpack, we're going to literally do for B in backpack. So this will just go through the entire backpack. And remember, in the backpack we're going to have items, so we can actually print out those items by doing print b dot print underscore item, open close bracket, plus, and let's just do a little dash, plus b dot print description. So if you recall, because we're going to have items in the backpack, we can actually call our methods we had in the item class to print out the stuff, and that will return a string which we will then print into the screen like so. So if the choice is equal to backpack, we're going to display the contents of the backpack. Okay, if the choice is pickup, if choice equals pickup, okay, there's obviously going to be an item in the room, and that will allow a player to pick up the item. So first thing we need to do is we need to check if pickup available. And if it is, we want to pick it up. So if you recall, we can use our current room object, so current room, and remember we had that thing where we could check if there was something to pick up. So if current room dot contains item, so if it contains an item, then we can pick up the item. I just forgot the if statement here. So if current room not contains item, pick up the item, else we're just going to print out there is no item to pick up. So when we're picking up the item, first thing we want to do is we want to basically print a message to the screen to say you picked up the item. So let's do print you pick up, and then we want the item name. So to get the item name, that's going to be current room dot get item to get the item, and then we want to print the item from there. So it looks a bit long, but basically we're going to get the item that's in the room, and then we're going to print out the item name, and then that's going to say you pick up hammer, or you pick up fish on a stick, or whatever it happens to be. Then of course we want to remove that item from the room, so that's going to be current room dot remove item, and that will just remove the item. Now you might recall that some items add to health and add to attack, so what we're going to do is we're going to pop that in practice. So if current room dot get item, so this has to be before the remove item, otherwise you're going to get problem dot, I believe it's get add health, so dot add health. So if that is greater than naught, then we want to do something, print the item adds plus plus health, so however much health it might be. So in this case we want a string, and it's going to be current.item.add health. We need brackets there because it's a method. Remember, because the add health returns a string, returns an integer, so return that into a string. So there we go. So current room.add health, and then we can do the same for attack. So if current room dot get item dot add attack open close bracket is greater than naught, then we can basically do this here, but we can change that, the item adds current room dot get item add, so we just change that to attack. And of course the one thing we haven't actually done is we haven't actually implemented that. So here we just do health equals health plus, and then it's this again. One of the trouble with object oriented programming is you do get these fairly long things, but hopefully you understand what's going on here. So we're in a room, that room's got an item, so we go to the room, we get the item in the room, and then from the item we get the health. And this is called dot notation. You need to get used to this. This is sort of narrowing in what we want. So the same thing is going to be true for the attack. So attack equals attack plus current room dot get item dot get item dot add attack. There we go. So this will now pick up and remove an item if we so wish it to do. So that's the two choices. We've got backpack and pick up. We're going to probably add some more in. So let's actually do our check for item now. So because we've actually got a bit of code here we can just copy. So if current room dot contains item, then we're just going to print out the name of the item, and that's going to be this line here, basically print item. So we're just going to literally copy that and then stick that in there, and instead of seeing that it's just going to say the item name. So UC, there we go. So that's a nice simple and straight way of doing that. That's good. Check for the master computer. Again, that's going to be, well, we'll come back to that one. Let's do display room description. So that's going to be literally current room dot, and then it's display description, and that will print out the description. So far we should be able to see the room description, check for an item, pick up the item, and check for the backpack. Where things get complicated is where we check for the exits. So before we start the input section, we need to look and get the exits. So to do that, we need to check for the exits. So check for the exits, and this will use the link item. Now I recommend what you do for this is you just copy the code that's already been done, because this is where it gets slightly complicated. So basically we're going to create a list called V, and V is going to contain all the exits. So we're going to have valid inputs and valid outputs. So the inputs are sort of north, south, east, west, and valid outputs are going to be the rooms they go to. So let's create those lists first. So valid inputs equals boom boom, and then valid outputs equal boom boom. And then what we do is for L in links, so we're going to go through all of our links, and we're going to check that if L dot, and one of the methods in the links file is contain room, current room. So we're going to see if any of the links contain the room we're in. If it does, we're going to add that link to the input with check valid current room, and then we're also going to add the actual room by doing our valid outputs dot append l dot get exit current room. So don't worry too much about this. All you've got to remember, all this does, it goes through our links. So room 1, room 2, it will check if the current room exists in the list. If it does, it will pop in links. So room 1 has a exit west, so there will be a W in there, and the output will be room 2. So that's what this bit here does. So what we then have to do is down here in the choice, is that's where we get to actually do something fairly complicated, not too complicated, but this is where we have to check if they've put in a valid movement thing. So they can't just type in south all the time. So for v in valid inputs, so this will go through all the valid inputs they have, and then if choice, which is the choice they type in, equals v, so basically, sorry, that should be a variable. So if they type in W in room 1, that should be a valid choice. So if choice equals v, then not valid equals false. So that will make us come out of this loop, which we're in here. And then the old room, well, and then what we do P equals valid inputs dot index v. Now what this does is this will get the, right, say here we've got valid inputs, so we've got west, north, south, and they link to room 1, room 2 and room 3, just for example. What this code here does, p equals valid underscore inputs dot index, so if they typed in n, that would say, well, that's at the first index, so not 1, so we want room 2 because that's also at the index, so it just matches them up. Okay, I know that's a tad confusing, but that's what it actually does. And then we do current room equals valid outputs, and then we just go boom p. So I suggest for your game you just basically copy that code, so for L, so check for the exits here, and then that will actually do the exit bit there. So far we've got a basic working game that will allow you to actually move between the rooms and pick up items. At the moment it won't do anything about the aliens, so let's just come out of here and just show you that briefly. So let's go to run, and we obviously don't want test, we want to do game, so test is no good. So run, no, I don't want that one, I want game. Yeah, so run, there we go. So right click on it and go run game, and whoa, lots of problems here. So what's happened here is, well, I don't know what's happened here, we've got a problem. It looks like line 14, so let's get our line editor on, so go help, find action, line number, show line number. So line 14 is alien 3. Now that's obviously not in display description. Right, so it seems to have a problem with probably item. So this is where we actually need to be very careful. Line 14, not item, room, probably room, I would imagine. So room, find action, show line numbers, line 14, print display description. Ah, I forgot the underscore there, so that would obviously cause a major problem. So that should hopefully fix it. Well, there we go. Right, that's better. So and it's not display description at all. It's obviously room description. So well done if you spotted that error. So go back and change that, and that should hopefully now work. string object is not callable. Well, you didn't say it was, so we've still got a problem here. Current room. So line 111 in here. Current room display description. That's good. String object is not callable. Item here. So the reason I'm leaving all this in is because this is what coding is like. You'll probably do a lot of this, but you've got to get used to checking using the error message. So type of string object is not callable, but what we have here, we have a clear room self.item print self.underscore from the script. So I've got that there, so get rid of those. Right, that should now fix it. So there you go. So health 10, attack 11, status display. Now you'll notice it doesn't actually display the exits, which is a bit of a problem. So if we go back to game, let's add that in. So we want to do that here. So when we actually stick in the exits here, that's when we're going to actually let it display what it's going to do and when it's going to do it. So let's pop that in, and we're going to print out the exit. So let's go print, and the link has a thing called l.print exits current room, so that will print out the current room. So if we go play now, there we go. So door leads to the west, so go west. Door leads to the north, let's go north. So door leads to the southwest north, so let's go north. So you can see this is all now working, and we're moving between rooms. So far the major problem we had was we actually had an error in our room function, so make sure that's changed, so that's the correct code for room. And what we're going to do now is we're going to add in the alien attack feature. So how the alien attack features will work: if the room has an alien, it will attack automatically, and it will basically loop the attack until either the alien dies or the player dies. And how it will do it, basically the attack roll will be a d6 roll. So the alien will roll a 6-sided die, you will roll a 6-sided die, and it will be added onto your attack. And then the damage is going to be the player attack roll minus the alien attack roll. So if that's greater than 0, the alien takes damage. If it's less than 0, you take damage. So let's code that now. So here we go. So let's check for the alien. So first thing we need to do is we need to make sure that if current room dot contains alien. Okay, so let's stick that in there. I now just need to exit presentation mode for a minute. There we go. So contains alien. So if current room contains alien, then we're going to obviously fight the alien. So to save the problem we had with the item class, you know, where we had to keep saying current room dot get item, let's actually get the alien first. So alien equals current room dot get alien. So that should save a lot of hassle, and if you were being correct, you'd probably go back to the item class and change it there as well. But we're not going to. We're going to leave it so you can see both ways, and then we're going to print out there is an alien, which is never good, and then we're going to print out the name of the alien. So alien dot print alien. So that should display the name of the alien. So now we do our loop. So while alien dot get health, so that's basically a float, is greater than 0, and our health is greater than 0, we're going to do the attack. So let's do the alien attack roll. So alien attack roll, so let's call it AAR equals random dot random int 0 to 6, and that's going to be added to the alien attack. Alien attack, get attack. There we go. So that's the alien attack. Let's do the player attack roll, and that's going to be exactly the same. Random int 0 to 6, and that's going to be added to our attack. And then what we're going to do, we're going to see what damage that takes. So damage equals, and that's going to be our attack roll, take away the player attack roll, so attack roll minus alien attack roll, and we're actually going to divide it all by 4. So that would just mean if you really overpower the alien, it's not a complete and utter waste of time. So damage equals player attack roll minus alien attack roll. So let's stick that in brackets and divide all of that by 4. And then what we want to do is we want to check if damage is greater than 0, then that's going to be an alien gets hit, else the player gets hit. Player gets hit. So for that to work, so let's do the player first. So the player is quite easy because if the player gets hit, it's going to be a negative number anyway. So that can literally be health equals health plus damage. And let's print out you were hit for plus, and then we want to turn that into a string, and then that's going to be damage. So you were hit for that. Now the reason it's got that grey line is because you could actually do health equals plus that, but we're going to keep it like that just to make it a bit clear what's going on. So that will do that. Now what's important to do, let's check if you're dead. So if health is less than or equal to 0, then you're dead. So print, let's do something like you die cold and alone, and then we want game over to be true, so that will stop the loop. And then what we want to do is we want to use something called a break statement, and that will stop the rest of the while loop running. If we don't have that, it will still carry on with all of this, so that's no good. So break there. So that will basically kill you off if you get killed. And up here, this is where the alien gets hit. So alien dot damage, and that's going to be damage, so the alien takes damage. So print the alien gets hit for plus string damage. So there we go. And then let's print out how much health left it has left. Well, actually, let's check if it's dead yet. So if alien dot alien health is less than or equal to 0, print that was a fatal blow. The alien dies, like so. Let's do current room dot remove alien to get rid of it. Now why is it not liking that? No, it's not liking that because it's not, that is get health. There we go, get health, else print the alien has plus string alien dot get health plus left. So basically this will either say the alien was dying and remove the alien from the room, or tell you how much health the alien has left. So that works out quite well. So that should hopefully work for the aliens. Now one way we could test that is we could go to a room that has an alien in. So room 4 has an alien in, so let's change the current room. So that's the room we start with room 4. Come out of presentation mode and let's run the test. So there you go. So the alien gets hit. Right, so it's a great. That's 8 health and 8 attack. And we have 16 health and 8 attack. So alien gets hit for 2. Alien gets hit for 2. Alien gets hit for 2. Alien gets hit 1.5. The alien gets hit for 1.75. A fatal blow. The alien dies. So that's brilliant. So the alien bit's now working. So you'll notice how quickly we're actually putting this together. So let's change the current room back to 1. And now all we need is a way to actually win the game, and then we're pretty much finished. So how we're going to do that is, if there's a master computer in the room, we're going to just say there's a master computer in the room, and that will enable the player to type in the keyword code, and that will enter the winning bit. So just right here though, right at the end of the loop, so why not game over, we're just going to print thanks for playing. There we go. So let's check for master computer. So if current room dot contains master computer, so if it contains the master computer, let's just print out you see the master computer. So there we go. And then if you see the master computer, you can actually put this in. So let's go between choice and pickup. So if choice equals code, then if current room dot contains master computer, then we can enter the code, else print there is nothing to enter the code on. So how this is going to work is you should really check your backpack first, because otherwise things will get very wrong. So we're going to do player A equals an integer of the input code A. So what that's going to do, it will let the player input code A, and we're just going to literally copy and paste that and do B, C, D and E. So B, C, D, E, there we go. Code A, code B, code C, code D, code E, there we go. And then we're either going to win the game or lose the game. So if A equals PA and B equals PB and C equals PC and D equals PD and E equals PE, then print, you input the code and win the game. Yay, go you. And that's obviously going to set game over to true. Even though you've won, the game is now over. And break out of that, else print the code is incorrect, print you get time to swear one last time before ... print boom, game over equals true, and then break. So what you'll see here is we have now finished writing the game. So the game is actually now finished, and it should hopefully all work fine. So now let's actually test the game out, and we will see. Now it's likely that the first time we do this we might encounter some problems, so let's actually have a look. So let's exit presentation mode. Now hopefully I will zoom in on this bit down here so you can see the game in its full glory. So let's run the game. So we're going to go west, piece of paper, so we're going to pick that up, and then we're going to go north, then we're going to go north. There's a fish on a stick, so we're going to pick that up. So if I type in backpack, or even backpack, no, that didn't work. Is it backpack? So what's the key for backpack? To get that, it was backpack. I don't know why that. B-A-C-K, P-A-C-K. So at the moment, obviously the backpack's not working, so we need to sort that out first. So let's come up to our code. If choice equals backpack, B-A-C-K, P-A-C-K, and choice equals input dot upper. So that should, for B in backpack, did we remove the item? So when we pick up the item, we do add it to the backpack, don't we? Because that would probably be, I bet you we did, and I bet you we missed that. Yeah, so we didn't actually add the item to the backpack, so that's completely my fault. So backpack, this is why we have to test, you see. Dot append, and then it's going to be current room dot get item. Right, okay, so now we're actually going to put it into the backpack, so that always helps. So let's start again, zoom in again, so we'll go west. So let's pick up the piece of paper, so pick up. Right, so this is why we have to check. Make changes, we've got to check. So room object is not callable, so not callable seems to be, there we go, brackets that are out of place. So let's try one last time, west. So let's pick up, nope. Room object is no attribute get. I'm sure it's get item. So backpack dot append current room dot get up. See, that's an underscore, not a dot. Right. See the fun that programming is? So let's do that one. West. Okay, so let's pick this up. Let's check. There we go. So that's now working fine. So what we're going to do is I'm going to end that here, and then we're going to do a full run through of the game in the third video and just check for any final errors, and also just going to tweak it slightly just to make sure it's working as best as it can.